loud music. I'm wearing my tourist t-shirt. Oh. This shader's pretty cool. It's by this MSM01 guy. Looks like there's some crazy shaders that we'll be able to see. Yep. This goes here. Good. Okay. Right. So I have something that I haven't had for a long time on Strafe Client, and that is direction. I've for maybe a year, I've been fumbling around trying to fix the goddamn bugs. Oh, I might need that. No, I don't need it. Ugh. What's this? Integral. That's why I did that. Yeah. So I've just like I made this issue on the Strafe project. When did I make this? Physics bugs 8 months ago. But like the bugs are older than that. I wonder if this will let me just sign in. Easy clap. Come on, easy. G. What is G? What is G? Gamer lock. Oh, that's probably the gamer lock, isn't it? There's the num lock, the scroll lock, and then there's the gamer lock. Okay. Quick. Oh, it let me in. All right. Oh, review. We still scared of this pull request? Fix them. But um work on. Mr. Beast? Mr. Beast? What do you want? I got billed $100. Fantastic. I love that. Okay. Direction. I was saying I have direction. One bit. Thank you. Directive. Okay. Nice. Great. Oh yeah. Why is it saying that? What? Why would it not suggest anything? Oh, was there a space at the beginning? Scale 3. Yes. And then 3 position. This. Yes, that should work. Okay. Now text very big. Big one. Okay, so what? Oh, right. I can just keep it close. Okay, strafe, engine, physics, source, minimum difference. That's the name, and I'm sticking with it. That's what Trey said. He didn't say that. That's me imitating a non-existent thought that Trey had when he wrote this. I've determined that this algorithm is more general than it lets on. And I found that because everything is relative between 2 points. It's like operating on pairs of points. And that turned out to map directly to a Minkowski sum of 2 meshes, which means that this is equivalent to a different algorithm that operates on a normal mesh, not a Minkowski mesh. So like a Minkowski mesh is just a normal mesh, but it's a mesh that's the sum of 2 other meshes. And it was taking that in, it was like taking in 2 meshes as input and then doing this algorithm on it. But it doesn't need to be 2 meshes. It could just be 1 mesh as input. So this is called minimum difference. And what it's doing is if you have 2 meshes, it finds the closest point of approach on both meshes and tells you where that is on the mesh, what the distance is, and very excellent. But as it turns out, Jesus Christ, oh my God, ads. Twitch is just advertising to me. That's so cringe. All right, I'm gonna open up my chat instead of Twitch. There we go. Okay. So what was I saying? All right. So this is general. It's the algorithm is actually the same as closest point on mesh to point. So imagine you have a mesh. I'll do this. Like this is some kind of mesh. Wow, it's a mesh. So if I have a sample point that's somewhere around, I can like I can like find the closest point on the mesh to that point. And my claim is that the minimum difference algorithm of two meshes is actually equivalent to the closest point on mesh to point algorithm for a single mesh applied to a Minkowski sum of two meshes. And you get the same thing when you just do that algorithm, but on a Minkowski sum of two meshes. This is like a phenomenal revelation. It's gonna, if I can successfully convert this something or other, what is this called? Algorithm. If I can successfully convert this algorithm, then I think that the physics will jump forward quite a bit. Hi. Oh yeah, I wrote this. Hell yeah. Good job. Did I finish? No. Okay, I got bamboozled by this. I wanted to look at this part. Excuse me. Hits. Excuse me. So this is like this. So what's going on? Okay, think about this carefully. So to me, this code looks like we can return a value, but then if this is false, then we can return a different value or false that doesn't depend on this. Okay, so what's going on? We have this value that we know is less than this. Well, actually, we don't know anything about it. So what if this is equal to this? And what if that is 0? Distance is 0, and these are both 0. Then this is false. I assume that means yard. I think this is either this is wrong or this is wrong. That's a good insight. I'm gonna go ask Trey. Okay, we're doing it. We're doing it. Oh, it's not here. Nope. Whoa, there's a button for a new pull request? Okay. Oh, yeah. We're going to this file, view file, ER. So we're going all the way down to this guy right here. Test intersection. So okay, less than or equal to. Okay, let's think about this carefully. So, okay, we know nothing about this actually. Okay. Yeah, I don't understand. Exit radius. Interesting shirt choice. I wish I had more shirts like this. So this is expanding the closest point. Okay, let's think. Am I dummy stupid? Okay. So this is some number. We don't know whether hits is true or false. But if this is true, meaning this number is less than those guys, if we add a positive number to those guys, it remains true. And like less than or equal to, whatever, it's already true. It's already greater than or less than. So this is necessarily a superset of this. So then if this is true, then this is necessarily true. What about this is false? Okay, so let's say this is false. What if dist is equal to these? Then hits is false. We skip this, and then this might be different. But we still return the original value. Um, my logic prover is not working right now. Help, computer. All right. So if I go like, hey, I'm making a statement, implies. Okay, so if the first statement implies the second statement, then we're trilling, big chilling. So I forget how to do this. Okay. Better, I'll just like smash it in. All right. Does this imply that? Where is there? Oh. How do you like say given the conditions? What do you mean or? Oh, I see. Element of reals. All right. All right. Sure. Ooh. Uh-oh. Can I do like this? Reduce. Help. Reduce. Why is that different? Use your head. Use your head. Use your head. Ah. Pain. Oh. Oh, I can't. That's right. It has to be the same type. Oof. So when this is true, it implies that this is true. I think this is true. Um. Oh. Okay, that it just told me that it was true. Surely. Boom, 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 boom. Why is that in there? What are you doing in there? Or and. I see. I've messed it up. Reduce. This should give me the same thing as before. This. Okay. So it says that this statement is true as long as these are real numbers and exit radius is greater than or equal to 0. So, I have proven that this implies, if this is true, this must also be true, which is what implies means. This statement being true implies that this statement is also true. But it doesn't have to work the other way around, where if this one is true, it doesn't mean that this one is true. Great. What if it's not true? What if it's false? If this is false, then this is false. Okay. Okay. All right. I might just like unsend. It's not that important.
This guy's copying Lua code.
It's true. It's true. Okay. Okay. Okay, so what is reduce simplex actually doing? Okay, just don't talk. Don't talk. I'm trying to think. Oi, oi. Okay. Okay. I'm gonna write that down. Actually, do I need to write that down? Do I need? I'll just write it down. Okay. Um, Note: if hit is true, this if statement true necessarily values the true, i.e. hits implies let me send you the rewritten code. Oh. Um, hmm. Uh, 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 but if hits is false, then this path is possible, but this path is also possible. I see. I see. So false. Yeah. No, this is actually not a correct statement. I. Uh. Oh my god! I've almost drunk all the coffee. I haven't eaten anything. Okay, so I have determined an if statement means something. Great job. Yeah, pat on the back. Okay. Uh, mm, Notes. Notes. Okay. Okay. Excellent. Hmm. 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 Okay, so this is not. Um, so previously, I was thinking that this code is like it conflicts with itself. It's like not consistent, but I didn't actually read the logic carefully. And now I've read the logic carefully, and it seems to make sense. Where there will not be any inconsistency. Wait, does it does implies go the other way? Where if this is false, it implies that this is false. I can actually write that. Um, all right, watch this. Watch this. So this is how we do it. We take this one and we ask, does not this statement imply not this statement when exit radius is greater than 0? And we can do reduce on the whole thing. So let me just okay. So dist is not less than or equal to exit radius plus blah, 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 meaning it is actually greater. So if this is greater than this is a smaller quantity. So it must be also greater than this smaller quantity. But we also have this equals sign here. So what if oh no, it's false. What if it's equal? So I think there's this one case. But that's true if it's 0. So we don't enter the like implies statement. So if this is true, we know nothing about this. But if this is true, we know that this is also true. I'm asking if this is false, do we also know that this is false, or do we know nothing about it? So it doesn't matter when the statement is true. Okay, so dist is greater. So if these are 0, this is not 0. So if this is 0, this is not 0. And positive, less than or equal to. So this is positive if this is 0. And if this is positive and this is 0, this statement is also true. So I haven't really completed the logic in my head, but it looks like if this is true, it implies that this is also true. Okay, let's see what the computer says. Computer? Okay, the computer says that this entire thing is a true statement when this is a real number and this is greater than or equal to 0. So it's like, yeah. Okay. If hits is true, this if statement necessarily values to true. Uh uh um so yeah, this is actually true inside here, because if true, no, false. If false, then false. Okay, so I've worked out the implies both ways. This is totally consistent. Mm. Mm. Okay, I'm glad I moved this in here because that really just belongs there. Uh, yeah. Okay. So number 4. Hmm. Nice shirt. Arbit random user. That's sounds like it's a name alt. I think you've been to the stream before, and I said the same thing. So greater than 0. This is just to change the sign. Blacklist. So these are differences. UV in a circle, UV. Okay, minus A. So it's like this. We have a tetrahedron. And then we're doing negative A. Dot with negative A. So we're like seeing where the where the origin is. So what if the origin is okay? So if the origin is contained within the simplex, then it's returned as is. Okay, I do doobly do. Okay. Do I have a way to do this? Greater than or equal to 0. Yeah, so this is for sine. Okay, let's do one condition. PVW. Hail. Oh, it doesn't know. Oh, I haven't put the ding dong in. Oh, wait. I have. What do you mean? Minkowski mesh, vector 3. What do you mean unknown? What? Okay. Uh, so if it is 0, then cool. It's yes. If it's, and then it needs the sign bits of this UVW. UVW. P3. I'm trying to figure out an equivalent expression without needing this divide or multiply. So basically I need to flip the sign, but only if a value is true. So it's kind of like copy sign. Is that the same thing? Is it XOR? Copy sign is just copy. I need like an XOR sign. XOR assign sign. What would you even call that operation? I want to change just the sign bit if another thing is true. Otherwise, I would need like multiple conditions. Like I could do this is 0 or PVW is positive XOR UVW is positive. And that would be one of the three. That would be this one right here. So if it's 0, we're chilling. And this guy doesn't matter. If it's positive, and this one is also positive, then we're chilling. If it's negative, and this one is also negative, then we're chilling. So that's XOR. So this is effectively the statement I'm trying to build, but I want to do it with one of these. This is like you have to compare all the bits, and then you have to compare all the bits again. So I'd rather do yeah. So I could do. What if this is 0? Seems degenerate. So if you divide by 0 and then try to compare, that becomes infinity based on this sign, right? Infinity based. So it still inherits the sign. Is it going to say that these are not real? No, it's just going to not say anything. What is direction? Oh, we can do 0. Like that. I do believe. We need... I'm still not entirely sure if this is the same. Okay, if this is 0, then this is false. But it should inherit the sign of this. So what? It's more like is negative is negative? If this is 0, it inherits this one's sign. It's copy sign to the output. If this one is negative, it toggles the sign. If this is positive, it inherits this sign. So it only matters if this is negative. So false, false. False, false, true. False, true. False, true, false, false. I think this is it. All right, I'll just write it like this because like I need to move on. Oh, look. We can reuse this calculation. Is this const? What happened here? Oh, I see. That's why it's not giving me anything. We have no other errors. Okay. Yeah. To do, reduce this. Okay. Okay, I understand now. Very good. Wait. Oh, okay. Okay, so we're removing the component of these to compare which one is the smallest. I don't really understand the UVW. UVW. Oh, is that just a determinant? Oh, okay. Okay. Okay, so it's just a determinant. And then these are like actual actionable values. PVW. Oh, I see. It just wanted. Okay. Mm. Okay. Well, that's a good thing to get done. I got stuck on this yesterday. This is like how many days? 17. What is it? 21? 24. What is that? That's a week expired cream. I can't even tell. It's so difficult to buy coffee cream because you can get a giant bag of coffee creams that expire in like 2 weeks. You can get like a big carton that expires in like 2 weeks. So I'm buying like the smallest amount that I can, and it still expires. Ah! Ooh. Mm. Okay, we're doing one of those minimum games again. Does it make sense at all to cross multiply? So this is extracting woodist to p. Okay. Woo. Hey, the algorithm is complicated. But after talking to Trey, I do understand what it's doing on a high level now. Hmm. Cross multiplying, it would get like mega wide because this is already 3, and then this would be 2 plus 2, so you get 7. That's really wide if you're doing cross multiply. Mm. Mm. Yeah, no, this is actually a four wide operation. Is this the same at the top? No. Uh, all right. Just read it. And then I'll deal with the fallout after. Sine. Um, so this is like sort of compose sine. Is that the same thing as this? Yes. So effectively, this could be up here, and it could be multiply by UVW sine right there. And that would be the same. Yes. So if I do this up here, I think that's better. So, I need a good name for this, like XOR sign, but it's not entirely that, because you can have 0 as well, and then it becomes 0. Mm. 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 It's not quite the same because of the division. Uh, 0. It doesn't make it 0. So I actually have two different operations here. I have I can do div sign and mul sign. That would work. So div sign would kind of be like if it's divided by 0, then like it's hands off. Whereas mul sign, if it's multiplying by 0, then the new sign, that the entire value becomes 0. Okay. I wonder if I bet I can make this const as well. So this is actually a new library feature. Is 0, is negative, is positive. Surely I can do this. Mul sign. Oh, it has to be. Should be fine actually. Yeah, I need another one of these. Mul sign mg. Other reference to fixed n1 f1. So we do not care, but it does return that. Okay, so we need is negative, is 0. Okay, if other is, wait, is this a reference? No. Full copy? I can fix it later. Is negative, then return self dot how do I that's a const, right? Yeah. So it's negative, then like that. Else if other is 0, fixed 0, we have to return 0. Else self. Yeah, so this is like return the result of self times sign other. So yeah, then we also have div sign. So this case is not real in div sign. Oh jeez. Um, uh, divide by 0 does not change the sign. We could return like a none here. Yeah, this would be better branchless, but I don't actually know. Does this also does this also have branches? Huh. 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 Hmm. Yeah. Math library. Mul sign div sign. So this is now div sign not negative. I don't know if that's fewer operations. I guess it can be because you can end up with this. Um, mm, so div sign is not the same as mul sign, unfortunately. So here we go. PVW mul sign UVW. Div sign, excuse me. Sign UVW dot is negative and then not like that. So the condition is a bit nicer here. UPW and UVP. Should I put it all in one line? No. Cool. That's a little bit reduced. So now we also have mul sign. But it's doing lots of copies, but like it's still gonna be less work than the other stuff. I can make this library better later. Relax. Okay. UV dist. UVP. Mul sign. Okay, so this. UVW. Mm. UV length, that should be 4. And this is 3. Five is not that bad. Um, Wait a second. No. Well, yes, UVW. No, we just need the sign. The W needs to stay out. All right. VW woo. And this stays UV sign. Woo. Okay. So now we're doing min. Do I have a freaking ratio min? This is why I wanted a multiply instead of divide. This is such a wide calculation. Honestly, I think I should just avoid the division at all costs. It's expensive, but I think I'll do it like this. No. Yeah. Oops. The last one. Okay, so now this is giga wide. Is this real? Whoop. True. Yeah. All right, fella. Let's go with this for now. And then, a component for RMA. If I did, I don't remember. I feel like I would remember because it's usually like a annoying process. Caffeine attack. Oy. So VWP is not real. It's wait. VW. Well, Yeah, it's this one, right? BWP. And then whoop is up poo. Like that. Min is min real? Do we have min? Really? Uh huh. Yeah. This is gonna be hard. Okay. Okay. So we've got this like just atrociously long calculation. Wait, length. Square rooty. So this is 8, and this is 3. It is not pretty. This is not pretty. It's also. Mm, ooh, ooh, ooh. Oh. Oh, never mind. No. Okay. No. Okay, it's just big. Okay. Um. Hmm. Else if. Okay. Mm. So what do I do on the other ones here? I see. So I moved it like this. We can do like this. And then we need mute UVP. Oh, PVW. Okay, so BC equals CD. So simplex B equals C, C equals D. So B is 1. That should be it. So it moves this one down, it moves that one down, and then we do the pop. Okay, more. So this is the other way. Yep. Okay. Underscore UVP. Okay. Ooh. So B equals D. So this is 3 now. And then C equals B. So we got to do this first. 2 equals 1, 1 equals 3. Ay. So this is like deleting one of the vertices. Wait. Is there a remove function? Hold up. Simplex dot remove. That's exactly what we're doing here. So look, we're removing B, which is number 1. I'm going to save this for later. Yes! Okay, I figured out something awesome. Height. Okay, so yeah, this is just remove the last one. Which is equivalent to remove 1. Because the length is known to be 2. So 1 equals 2 pop is just remove 1. Oh, halt up. But it's not quite the same because we also remove number 2 here, even if it wasn't swapped. So, I don't know. Do I call... it's like... I think remove is better. I'm gonna do it after though, because I have more work to do here. Hobbly gobbly. Okay. Oh. Up you. Up. Okay, so we got the stuff. So we do let ding equals dung. Sure. Dot. Lower. Okay. Is this? No, it's just a new calculation. Okay. Ooh, okay. UV up, UV PV. Shrimple compared to what we've been doing. All right. If UV up is negative, it's not negative, then that means it is either 0 or greater than 0. Same with this other guy. And this is and. This other guy is not negative. Okay. Close. Okay. Okay. If UVW is wait, what? Bool. Oh, it's an if statement. Okay. Is negative. Then return UV dot wrap 1, surely. Or wait, no, we're doing narrow. And then simplex, easy clapping. And then else negative. Did I don't make a negative? Whatever. Sure. Okay. Negating the output of unwrap is easier. Okay. Yep. Gimme. Up V, up U. Do we need that again? Yes. So let me just make sure it's actually the same, because it's probably not actually the same. All right. Ooh. Ah. Ooh. Ah. Ooh. Okay. Okay. It is actually the same. Uh-oh. Here, I can do this. D. There we go. It's the same. Okay. Next. VDist equals MINDist. Then that means V less than U. Surely. So we're going like this. V is the goober. Okay, so then negative PV, negative UV, UU equals VV. This is exactly the same. B equals C. B is number 1, C is number 2. This is exactly the same. Excellent. PU. Yeah, I'll just copy it. I need to pop here. All right, so let's see. PU is P dot U. So we start here. And then if this is greater than or equal to 0, then direction is up cross U. If direction magnitude equals 0. Not quite there, bud. I almost got away with it. It's not the same. So this is actually the same as this right here. UV less than 0, UV. Is not the same. That's GG. Oh. Yeah. Yeah. Okay, so that should be the same as that now. Or not the same, but like should do that code. It was not quite the same. Always gotta look. Hoi, hoi, hoi. Okay. Last one. What do we got here? Alright, we need one more pop. There it is. Hoi, hoi, hoi. So we start here. If direction equals 0, then we need this magic again. Surely. Okay. So this one was wrong. And that's GG. Ooh. Immutable here and immutable here. What do you want? Oh, It's not good. Okay. Maybe this will just turn into dead code. That would be good. Okay. We did it. Work. Okay. So we now have a completed reduced simplex function. Holy spamoli. What do you want? Variable does not need to be mutable. Is that real? Okay, that is real. So this is unused. Okay. Okay. Should I just delete it? I think it's fine. I'm gonna comment it because like I'm still in the process. So it's need to be like that. Remove unused. This is not quite the same thing. Okay. So that's all of the blue underlines. Okay, so now what I want to do is change it to instead of popping, I do remove. Okay, so that's every single time for every single one of these. And I think that's nice. So we start here. Pop. No. Remove. Number 1. Yeah, so we start with 2. Then we remove B. And that is actually what's going on. A, B, C. Looks like I forgot a pop here. Oh, no, it's here. Okay, so then now instead of this, we do else. So this is remove 1. And this is remove 2. Either way, we're removing one of the vertices of the simplex. Yar. And this should be always remove 1. Okay. Next, so 1 equals 2, 2 equals 3. So move 2 down, move 3 down. We've effectively removed 1. Okay, and then what is this one? This is 2 equals 1. 1 equals 3. Oh. Oh, this is actually a swap and pop. Okay. Do we have this? Do we have like swap remove? Simplex dot swap. Swap, pop it and swap it. All right. I believe we can do swap remove. All right. 1, 2, 3. Swap remove 0 moves the last element into 0. So 3 moves into the front. And if we do swap remove 1, we've removed 2, and it's like fine. Okay. Okay. So what? So we've put the last element into 2. So removing number 2. Oh no, that doesn't work. So we're deleting C because it doesn't appear on the right hand side. But we're also modifying 1. Okay, what about swap pop? Remove an element at index and swap the last element into its place. Oh. Wait, 1. That's right. So I think that this is too complex. And we just have to do it like this. And then else remove 2. Oh. So I could do swap. So this is so I could do two. Oh, yeah. Well, 1 equals 3. So that's like this half. It's this operation, like this. This operation is the second line here. So I can do 1 equals 3. No, I can't. I'm trying to like shorten this into 2 lines of code here. What about this one? C equals B. So that's 2 equals 1. So I'm taking B and D, and I'm putting D into where B used to be, and there's like an empty space here. And putting B into where C was, and then destroying the last element. So I need to swap and then swap remove. But it's not obvious. So swap, that's do I need both of those values as well? C. No, I only need C equals B. So that's 2 equals 1. And then this is a swap remove. So we have A, B, C, D becomes A, D, B. Before transformation, after transformation. Okay, so now it's just 2 lines of code. C is removed, but we had to change things because of the way it is. Oh my God. Okay. Okay, so now we continue with our disastrous refactoring. So this is 2. We're removing 2. B equals C. Remove simplex remove 2 yar. And then this is remove 1. Yes. No way. And then this last one is just remove 1. Okay. This is a bit more involved than I thought, but remove is more clear. Okay, so this added code, but that's okay. Because, like, oh, we're removing vertex number 1. Oh, instead of like, and it's like, huh? What? Equals pop? No, just remove 1. That's what it's doing. Okay. Good job. Good job. All right. What if I just do this? Let's go. Let's go. Okay. Big coding. Such skill. I'm so skilled as a programmer. Okay. I kind of need to go to here because like the point of this optional value for the return value is that it knows, and it's like already like in here. It's just ready to run this whenever you feel like it. How do we know? So this actually needs to be an optional thing. I gotta. Oh no. Okay, no, the constructor needs to be an optional thing. Oh, right? Because then it's like it's running this schnack. It knows for sure. Unexpanded. Okay, so unexpanded. It knows for sure it's like that. But then expanded, it doesn't yet know for sure. You gotta be like, oh, check. Oh. It's tough. Uh, Yar. So I think that this doesn't make sense. I actually have no idea. I think this is like two stages here. The first stage would give like topology information. So if you only care if it's intersecting or not, then you don't need to calculate the topology information. And you're like, all right, bool, nice. but you can use the sum none as a bool and just not evaluate the details. But then after you evaluate the topology details, maybe you also want to evaluate the real details, the like actual what was the closest point on P and the closest point on Q and the normal vectors and the distance between them. Tell me everything. So I think that there's two levels here. So I think that this is an enum, and we have expanded and unexpanded. And then this is like topology details. So here we're gonna have pub. No. Oh yeah, no, that is pub. You goob. Expanded something self, and then something, and then unexpanded. Which one was optional and like we didn't know? So unexpanded. Brain. Expand, decompose. Okay, so this one we know. Unexpanded, we know. Unexpanded, we know. But this one we don't know. Yeah. All right. Just give me a sec. Yeah. Sure. Just. Okay. What do you want? Did I not change it? Stupid. Okay. So. This is. What is this? Euclidean details? Particular details? I don't know. This is like more details. I don't know. Self. Yep. Self. Yep. Probably I want to consume self here. But I mean, like, it doesn't really make sense to like reference it. It's just consume it because you're like doing the final calculation. Rel pause. For real. This is topology. Should it be called details? I mean, so the topology information is the topology information, and then from topology, you can calculate the exact goobs. Yeah, so like this is the topology, and then this is the details. Yeah. Okay. See how it's the same. So the details runs this calculation. Yeah. Okay. Why is there a second if statement? Don't we know for sure? Huh? Okay, so please, sir. So something like this. So you get your calculation, and if it's sum, it's intersecting. Great. I'm so happy that I have that information now. Throw out the topology. We don't care. No, throw out the result. The unlike built up result. We don't care about the further information. Oh, actually, I can smash this straight in now. So unexpanded is the chill one, right? Let's go. And then this one is the not chill one. We gotta do like this. Yes, sir. Oh, it is a pump function. Okay. Refactor calculation result. So huge. So huge. Okay. So it's the way you use it. So this code, instead of just being embedded inside of the thing with if statements, it is there's an object that gets returned, and then you ask for this additional information, this additional information afterwards. Good progress today. Huge W. This makes a little bit more sense. Okay, I still need this algorithm and this algorithm. Those are things. Nil. Is that GUI or is that possible? So like basically I don't actually know if like this stuff can fail. Because like maybe this should be an optional value as well, and you might not actually get the topology because it's like it can fail or something, but it's confusing. Yeah. Okay, here's what I think. I think that this is the topology information. And this is the like exact goober doober information. So we don't need so like this path here is a no-op when we want topology. You like already got it. It's like it's right there. Oh, I'm so glad I wrote this down. This is so I think this goes here. This less than or equal. Why is it different? So I think it's because we can calculate the topology. No, the exact stuff. Even if it's exactly touching. So wait. So I want this optional value to mean hits. So the return value of the calculation tells you whether or not it's intersecting. I am now realizing that does not make any sense. I'll be right back. Okay, it's exactly backwards. So minimum difference. If it does not intersect, then we can prod prod we can I don't have the word. Make it further the calculation, continue the calculation, and extract details. But if it did intersect, so we need this regardless. Discuss. And then we just need a hits method you can't know already. Is that true? Couldn't I say like yes hits, no hits? Okay, I think I understand. The problem, okay. Well, no, it should be fine because it always starts on the surface of the Minkowski sum. So it will never guess a point inside because it's always doing the farthest vert query to begin the calculation. So that's always guaranteed to be on the surface of the Minkowski sum and not some sort of invalid internal combination point. So it should work. It doesn't have the greatest computational complexity, but like I don't really expect there to be meshes with more than like 20 vertices. So it's like O of n where n is vertices. So repeatedly asking what's the farthest vertex in that direction and then just checking all of them is fine. If we have a mesh with a million vertices, that's kind of not good. Like it's doable to accelerate that calculation and like um, have a tree of directions where like you're splitting directions in half, kind of like a BVH, but just for directions. And then now you can binary search directions to get surface points, and like, yeah, that's faster, but generally the meshes are not supposed to have lots of vertices. So there's a way out. Okay, so this is like totally wrong. Thinking. So I just have to ask it, right? So you always you always can ask for topology information. There's no optional involved here. You just are always able to ask for topology information. Arf. None. Okay, so this is actually like basically wrong. Okay. Wait, nil. I need to see the code. Stop being full screen. Okay, so this says return false. Okay, exit radius infinity greater than infinity. So okay, so exit radius is supposed to be like a fast exit. This doesn't work with my okay. So this is ahead of time. So this is like you have to know ahead of time whether you want topology information or not, whether you care about it. I wonder if I can pull that through. Abs that is 0. It like skips this work, which is valuable. Okay, yeah, I totally got it wrong. So it's not that you have the topology information when it's intersecting. You don't have the topology with information when it's not intersecting. You can always extract the topology information. But sometimes you don't care about it. And in the old algorithm, you don't care about it when you provide an exit radius. Exit radius was like necessarily, we do not care. I'm gonna have to rethink this. Cause this needs to know ahead of time whether you care. Dot vert next point. Getting close. Ooh. It was easy with XFX. AMD brand. I actually have an XFX graphics card in my cupboard. I and I owned one. I bought one before as well. Yep, it doesn't work. Sent me a replacement. Awesome. That's how long has it been since you sent that message? It's been an hour since you sent that message, and I just read it. That's focus. So I could totally omit this calculation here, and then it would go through this one and end up with the same information. This is just an early exit, a low complexity early exit condition that so what I could do is like try to constant and have like some sort of shared code compile time return value thing where if you there's like two objects that have the function and the return value is different, and then this is like different implementation, but compile time. I can no longer see the clear path. Because, like, at the call site whether you care about the topology details and stuff. So I thought that you may or may not get the, like, result of the calculation. But that's simply not true. You always should get the result of the calculation. Unless you only care about whether or not it intersects, whether or not they're touching, and you don't care about the topology. You don't care about the actual distance, like whether it's like -1 units or like is it deeply intersecting, is it just on the surface? We don't care. It's just intersecting, and that's all we care about, or just not intersecting, and that's all we care about it. I will need to ponder. This is also unexpanded. The topology. Yeah. So then. Yeah. Okay, so topology goes right here. What if I save the loop state? What if it's a freaking like state machine? That's kind of like async programming, actually. Oh god, I could do like async 08 points, and then pull the full state machine. That's insane. I would just like make my own thing instead of using async 08. I'd make a little thing, but it's still doing extra work because we actually can just completely skip the calculation under one condition, and that's that we care about the topology information. This calculation can be skipped because it doesn't tell us about the final topology. We need to go through more stuff to get there. So if you know ahead of time that you need the topology, you can just skip this part of the calculation. What Trey was doing before was he set exit radius to infinity when you don't care about it. And it just sort of like, this is a pretty cheap calculation. So it just kind of like rolled by it because it was just always false because what, you're going to have a value bigger than infinity. But I think I can do better. I think I can completely omit the calculation when we know for a fact that we don't need it. We know for a fact that we want to continue through the calculation and get the topology. So like, okay, so like, there's like, this is kind of a trait where like the minimum difference is returning something that implements the like minimum difference result trait. And then there's 3 implementations of that. There is test intersection, topology, and exact details. And all 3 of these will run differently. ER. But I don't want to have duplicate code. And I don't know how to do that. My brain is full of traits. So like, yeah, there's lots of ways to do this. Like, currently I have this like enum. I think I'll still need this because of the expand thing to grab the topology is only needed on one of these branches. And I think that's unavoidable runtime switch. But I do not have a clear picture of everything. So expanded is here. It means we directly have topology, and these are the same calculation from what I can gather. Return accuracy. Oh goodness. Oh goodness. Right. Volume, what? Abstat. Oh, it's so complicated. So I think expanded is like literally topology. And then unexpanded is not. It's like something else. A, B, C, D. Yeah, so topology is just a simplex. But it's always ABC. No. No. Expand. Expand is doing norm dot minus dis. Jeez. I think that's what it's doing. Ugh. I'm quite lost. I should probably write them separate, and then maybe I'll see how to fix it. Yeah. This is after. PQ. Yeah. Um, so yeah, I think that this is this calculation. The details calculation is this. And um, just like this, right? So this is an exit condition. Return false. Exit radius. Confusion. Come on. Like that. Set. Yeah, I think that there's a job here. Where we remove this, and there's function hits. Cool. And it consumes self. This actually does something. What do you want? Function takes one argument. True. So this would be your path. But really, you know ahead of time. You know ahead of time. You know. You can literally call a different function instead of this one. So you could have like minimum difference is intersect, or like does intersect. You could literally just call it that. Also known as point in part. Is point in part. And then you have, there's three. I explained this. Point in part, topology at point of closest approach, closest topology of the distance information, and then the actual distance information itself. Three levels. I just don't have it in my head how to do that while sharing code. As much code as possible shared. Because like this only applies if you only care about intersection. Otherwise, we can omit this calculation because we know for sure we are going to go further with the calculations. We are going to continue the calculations. We know. And then in the same vein, this is a known hit, right? Well, I guess not. It's different in all of them. There's also a case where you know that this is a hit and like it discovers it on the next loop. It's like, oh. Whoa, 3 hours. Whoa, okay. Woof. Let's keep going. I'm so stuck on like omitting this tiny exit condition on the slow path. This calculation is very simple compared to the other stuff. It's probably still kind of slow. A lot of the stuff I'm doing is slow. It's really just carried by how fast computers are. Yeah, let me just multiply these two 1024-bit numbers. No, I never do that. The result, the largest result is a 1024-bit number. Const. I don't want to make it a macro because it's still like code duplication. So I gotta what if I could have a const enum. That'd be chill. But like the return value of the function is different based on it. It has to be like a trait. I guess I can like have an associated constant. This is kind of like goofy, moving code around goofy. I don't really know what I'm doing. Why don't I grab the master branch items and then rebase and then make a new branch. Min diff, rebase, yay. And then this is the same as this, goot. This compiles fine. I'm just gonna ignore it. The fact that it's like not optimal. Okay, we force pitch this. We pop the new changes, make a new branch called goofy, and then goofy stuff. Cause like I moved a bunch of code around. It's kind of goofy. Does this have a check mark? Yes. Okay, cool. Okay. All right. Trait time. It's a trait. So like this should be an operation on a mesh, but then it has to be like generic on another trait. So what I'm just gonna make it up. I'm gonna make it up. It's gonna be bad, but maybe I'll learn something. Let's see. Trait. MD result. Say it. Minimum difference. Say it out loud. Minimum difference result. So we have a type output. What? And then we have a const it do we care bool do we care about topology, about details? So like that would be equivalent to test intersection here. So we're just testing intersection. Just testing intersection. Crikey. It's a const. It's a const. Output. Const fast fail is output. Are you allowed to do that? Self output. Fast. So this is like, are we just testing for intersection? So then the other ones are like topology type situations. So let's see. This is fast. It's fastness. Fast. It's you're like const fast paths. God. Is fast. Fast fail. Jesus. So no. Yeah, what did I gotta do? Trait. Amazing. Okay. Then this is F output. And then so now we go like if F is fast and then can you see what I'm kind of getting at here, where it like can reasonably omit this if statement when you F it. So we're going to have this thing. Struct intersection just like test intersect. And then what else? Struct topology, but I already have something named that. Struct details. It's like return intersect, return topology, return details, and then like impl fast for each of these. So return intersect, this is what I'm thinking. Const is fast equals true. This is the point of this. And then type output equals bool. So literally the output of the function is just a boolean. Const fast fail equals false. False is it's like it just doesn't apply to everything. It's like JavaScript, but compile time, so it's okay. I don't know. It's like, okay, why did I say JavaScript? JSON. It's like the JavaScript way, where like if you have a bunch of endpoints for your service, and like some of them need this value, some of them need that value, you just make a big mega return type, and you just like have all of them in there, and like whatever, it just like they'll just be null values if they're not needed. And like some of these only apply to certain ones of these. Okay, so topology details. Hello. So what is going on? So return topology is like, oh my goodness, wow. Then false, and then fast fail equals topology like frigging underscore. Let's go. Irrelevant. I could just transmute nothing and it'd be just like instant UB. Anyways, because like it's supposed to not, you don't need it because this is false, but it still exists because like, how do I do this? Okay. And then same for this. So output is not bool. It is details. We go full details. We actually don't care about the topology, or maybe. Yeah. I could have, because you must go through to the topology to get the details. So I guess there's only two types here. You only need GAT1 and GAT1. Oh my god, bro. Oh my god, bro. Okay, so this is freaking R. Whoa. And then it's not const. It's a goddamn function. So I think it's like oh, so yeah, this is kind of like a function call. It's like the third function. It's like the third function of the trace. So this is like expanded something. It's probably simplex. Yeah. No. Like this, and then output. God, you got to do self all the time. So there's expanded and unexpanded, and then for this, it's like. It's return intersect only. This is like working. I'm like just making total BS up, and it kind of looks like it's gonna work. Actually, I could smoke this like this right now. Is there const? Simplex. Simplex. New const. Huge. Oh. Real. Simplex. Real. Real mesh. Yar. So in this vein, I don't need this because I know that I'm going to run this code because I am in the skewert of the Dubert definition. It's like, yeah, we're going to run a bunch of calculations in here. Or like, no, it's just a bool value on the other trait. Yeah, okay. So this is the intermediate data structure. And then this goes away. And then this is in return topology. So it's like we got expanded, and that's that one, right? It's the one that's expanded. And then we got the not expanded, and that's the other one. It's the other one. That's what it is. And then we know for sure. This is the other one. Expanded. Like this. Return hits. This is why I'm doing this. This if statement is compiled away to this trait. And the true path of this if statement is this monomorphization of the trait. Understand? Yar. Direction. Who knows? Nobody knows. Okay. So then there's another one. There is unexpanded. And I think that's just like true or something. Like we know for sure it's going to hit. And so I don't know. True. Ooh. So that's what was in my head. That's my first idea. So this is a R, like this. And this is also a R, like this. And the hope is that this is big const, just like massively const. No way. So like fast fail for topology will never fire because it's const. So this value is literally just irrelevant. I'm going to write that down. This value is irrelevant. Exclamation point. Is that okay? So return intersect unexpanded means true. It always means that we found it out, boys. We did it. Okay. Oh. I think so. Intersection is guaranteed at this point. So like, this is like outstandingly complicated just to remove one if statement here. Kind of. It removes several if statements. It removes the other ones that I deleted. Yar, right? Where? Oh, yeah, here. So this if statement is no more. It's const. Yeah, go. Get out. No. Const. So we can just say unimplemented and just like, yep, I don't know what I'm doing. Did you implement it at the top or at the bottom? I saw him make eyes at you. No way. So, so this is like what do we care about? This is like with care for intersections or with care for topology. I can do both, and like compile time, it goes away and it does less work depending on which one you're doing. Both of them are faster because the call site knows at compile time which one. I can like keep this a private trait and just seal it inside here and then just make two functions that call with the specific Goobert Dubert. So like that would look like this. Oh my god. So it's like point in mesh. Yeah, watch this. So it's like point in mesh bool. No way. So it's minimum difference. And it doesn't know what it's doing. But if I go like, yeah, I go like return intersect, it's like, oh, that's what you mean. And that's like, I now have a function that returns whether or not the point is inside the mesh. And then I also have topology of closest approach. So get closest fev. Mesh pause fev. Yeah, bud. And then that goes like that. So you see how it's the same function, shares code, but it does different things. So like this if statement may or may not exist, and it may or may not exit early based on the trait. Does FN stand for Fortnite? That's what I'm thinking about. So this is dreadful. All right, I'm asking AI. I wrote something. Oh, these can actually be private. Holy moly. Insane trait just to remove one if statement. Remove if statements. Yeah. Okay. Trait. It's a trait. Oh my god, it's a trait. He can do it with traits. He's insane. All right. We don't do that around here. Spaces? No. Okay. Can you tell I'm caffeinated? Okay. Let's see. I'm gonna ask chat. Chat help. Are you done? Load it. All right. Here we go. How can I help you? Yes, please. My trait. Sir, my trait. Okay, the return trait is insane. How can I improve the design? Yeah, thanks. You need an AI, such a bad scripter. Right, but I like actually wrote something that will potentially do what I want first. It's just awful. Why the return trait feels insane. Constants in the trait are usually used to encode behavior. There's orthogonal data on the trait where something's in with a data type leads to a lot of boilerplate. Move the constants into a strategy struct or the generic parameter. Huh? Output is an opaque type. The color can't see what it doesn't instantiate the trait. With verbose hides the real type. Give the trait an explicit name. Type result. Okay, it's complaining about the name. Fair. Two separate indentations that are almost identical. Different in the data they return. Algorithm has a branch on it fast. That is the entire point. It's typically hard to follow. Forces the compiler generate two almost identical loops. That is what I want. Colors, I would keep. Yes, yeah. Accidentally mismatch. Clean strategy design. Keep the generic function private. Expose two thin public wrappers. That cut with a strategy closure. Yar? Confused pirate noises? But that's okay. No, not an enum. Boo. It's just exactly the same. And then now in the loop, it's like that doesn't even work, my guy. My good dude, that does not work. This is also wrong. This is also wrong. It just didn't. This is so complicated that the AI is totally lost. Closure-based strategy. Finish. Finish. Closure. That is actually cleaner. Let's try it. The AI actually came through, I think. Okay. Yar. Okay, so here how it work. Okay, so you go like, oh, this is just a t. It's a t. This is t, and then we go const fast bool, and then we go t. So we have fast and t, and we go like, oh, are you fast, son? Are you winning? And then I don't even. Okay, so then this is like. Do we want 2 closures? Are you making a B-hop algorithm? No. B-hop is very simple. This is physics. This is for testing if 2 objects are intersecting, or testing for what the point of closest approach is on the objects. Because like, oh, you gotta find like on both surfaces where the point is closest to the other object, and then actually give the distance, and then actually give like the normal vector and the actual points that are closest. Yar. What is this? It's a T. T T T T T T T T T T T T. This is like. I think this is gonna work. So there's 2 things. Expanded is a fn that takes simplex and returns t, and then unexpanded is a fn that takes simplex and returns t. Unexpanded, help, and then we do this, and then fast fail, I guess, is just directly a T. And then we go like this, and then none like this. And then all of this crap goes in here. Wow. So we go like, mesh rel pause. Mesh rel pause. And then we go like, that one, freaking a closure. That one, freaking another closure. And it just like doesn't exist. We do not care. Every value is irrelevant. I can actually use that comment. And there's no trait. No trait. Okay, so then here's your closures. You got it. One of them. Underscore simplex. So this is like, whoa. You're giving me a value, and then this is expanded, and then this is Dobby. So this is unexpanded, simplex, intersection is guaranteed, and this is fast fail, false. That is incomprehensible, but it was already incomprehensible before. Fast fail is false, right? Okay. But then this one, value. So then we do the same thing, but completely different. Expanded, unexpanded. Fast fail value. Const nigh. How big is this? Topology. Oh, who's got this? Oh, so yeah. Cannot infer the value of const parameter fast. Unlucky. Fast is true, by the way. And we don't actually care about this. And then fast is false, by the way. Okay. Does that actually reduce the code line count? Switch trait to closures. And actually, the benefit of this is that the closures can capture the environment. Is this a minus? It is a minus. How script heavy is Roblox Behap Surf? I mean, there's 20,000 lines of code in that game. Or is there? No, there's 40,000 lines of code in that game. So, very. Probably I want here enable fast fail, like that. That's so the closures can actually grab the mesh and like compute the topology and stuff. So that's nice. So it's like still freaking insane. But it's like reeled in a little bit. Maybe. It's insane but different. So like the trait doesn't have like weird stuff that's irrelevant. But the function does instead. Like this is only relevant if enable fast fail is true. Const. It's pretty cool. Can you do this? Or do I need to have two if statements? Probably the compiler smart enough to do this, right? Does this compete with any other game on Roblox? Combat Surf, kind of. I don't think it's really a direct competitor though. Okay, very insane. What about this? 64. Cool. That was hard to think of. I actually got outclassed by AI. It thought of the closure method, which is still like quite insane, but it does what I want, where I can have the code be shared. Self. The code be shared, but have it compile time if statement. T. Good work. Good work. That was some good brainstorming. Thanks, AI. Oh, I thought of this as well. Choose perpendicular to use match on min or match on a tuple. Recalculating the squared values. Match on a tuple. How do you match on a tuple for min? I do not have that. But it's for a good reason. It's because you need traits. It's generic across vector stuff. Lots of Sid mentions it twice. Yeah. Keep the algorithm pure. What the heck? That ain't Rust. That is a hallucination, right? Intersect only. It actually, these are like more descriptive names than I was doing. I called it return intersect and return topology. And it correctly recognized this is like intersect only. Like it's only returning the intersect information, like whether a Boolean of whether or not it intersects. And this is like the complete full calculation. So it has some understanding. It's very cool. Cool. So what were my... The return rate is insane. So closures is a good idea. And I did that here. but I still need to actually write the code. And then this, yeah, this is after topology, and this is also after topology. Topology. There's always topology. You always get topology. It does not fail. A function signature is infallible. Oh yeah, my skin is coming off. Y'all just ever shed? Quaternions lizard reveal. Gosh. I think I'm gonna actually just have this be a named constant. Enable fast fail equals false, and then like that. You know, it's just a bit easier to read. Oh, it also means that there's no enums at runtime. It just kind of like knows exactly what to do, which is kind of juiced. Code sharing. SpongeBob. Sometimes you only care about the topology and not about the exact point of intersection details. Stuff and things. Oh, wow. Okay, so yeah, okay. I think that's a good job. This trait was insane. The closures, also insane, but actually better. I think this is this true? Intersection is guaranteed. I actually don't know. Unexpanded intersection is guaranteed. Oh, the code's right here. Unexpanded. Yes, true. It is actually straight up true. Unexpanded, true. Huge. Just massive. Fantastic. Brain power. I think this wants hits as well. I might want to have hits and details separate. Wow. Topology. Wow. Oh my god, that was probably one of the biggest roadblocks. Haha, roadblocks. Was figuring out how to like have these two functions, point in mesh, is point in mesh. Yeah, so this is like contains point type situation. This is closest fev. Holy moly. Oh my god. Names. I will try to figure this insanity tomorrow. This actually doesn't belong in here. It belongs up here. How does this fail? Expand, return nil. I see. I see. So it actually is supposed to not fail. Cool. That helps tremendously. In fact, I can, that's actionable information. What about that? So it's guaranteed to hit once it's in here. So yeah, this is like probably I can just absolutely smash it through. So details. Oh, come on. Yeah! Isn't that great? It's great. Wait, can I do it even better? Should I not name it? I could just like whatever. It's fine. It's fine. Good. So yeah, it's just receiving this. Oh. So this is option, right? I guess I should have a custom type. Because this is like, um, closest point. And then point. Yeah. So if there is a closest point, returns none if the mesh is point is intersecting point no details. Yeah, closest point details. Yeah. So decompose point. I can just like not write this because I actually don't need it. Lol. I think I actually just don't need this decompose function at all. That's what I like to see. That's what I'm talking about. Okay, expand is kind of a bad function name. I guess all my stuff here is named after it. So this is kind of like approximate and exact. Refine. This is more like refine. I'm refining. Yeah, so expanded, let's say exact. So this is like the exact topology at the closest point of approach between the two meshes. And this is approximate topology at the point of closest approach between the two meshes. And then I can refine it into exact topology. Exact. Holy. Absolutely phenomenal. Okay. And then I actually just straight up do not need this. Okay, hooty doody. So function refine to exact. Something returns something. All right. Did I mesh? Okay. Yes, sir. Yes, sir. Okay. Refine naming. Closest point details. Expanded exact, unexpanded approximate. So it found an approximate topology of the intersection of the closest point location. And if you just need to know, is it intersecting or not? You're done. Nothing else needs to happen. But if you need to know duet topology, wait. Don't it be meaning, did I write this? Oh, true. Oh, wait. Is it algorithmic failure? Insane. So you have two functions. I found an exact closest point, or I found an approximate closest point. Found general area. Found an approximate closest point the meshes are intersecting. Found the exact closest point. Closest fev, I believe. I believe we can get it. Get it out. Should be another freaking generic const. Are you allowed to have a const generic with a type that's another generic? I expect not. Let me just try this. All right. What if I go like Oh, by the way, const fast fail t. Ah, you got me. You got me. I'm trying to do something insane. Nah. Uh, found enough information. Found enough information to conclude that the meshes are intersecting. Exit. Exact. Exit and exact. So intersecting. Do I have anything that's called like intersecting? I could just call it intersecting. It's like the intersecting code path that runs when they're intersecting, and it's known. You could also say like on intersecting and on exact. Oof. On fast fail. On exact non-intersecting. On intersecting is kind of the real full names here. Topology, information, and intersection depth can be computed if needed. At call site. No, not at the call site. Can be computed if needed. Is computed. Is computed if needed. No. Topology information is computed if needed. It's like intersecting procedure. This is exact non-intersecting. Is that true? Is that true? On intersecting, intersection is guaranteed. Obviously, because this is called on intersecting. Duh. Duh. So I can make, instead of having them be closures, I can make them like little function guys inside of here. But then I need to like make it. I mean, closure's a little bit insane. But I think it's not that bad. We have the fast path, fast fail stuff. Amazing. Oh, I think this is I think this is good. So I'll need to actually like figure this out. Keep going with the commented code and the unimplemented stuff. But I think I'll leave that for tomorrow. This is very mentally exhausting. And I did a lot of good work. In fact, 4 hours of work. That's 1 more hour than all my days last week. 4 hours of work. There's a lot of people in the world who work more than me. There's also people who like look up to me as the pinnacle of work ethic. It's just habits, and the habits are like weaning off time. I need to like build the habit back up, work longer, work harder. All right, before I go, is there any like GitHub activity? Damn. No pull request accepted. Feels bad. Oh. Okay. Well, I'm totally satisfied. This I just feel like I'm sailing directly at the a very obvious improvement to the physics engine. Progressing directly towards success. I don't really, this is so complicated that I don't really expect it to work first try. I think there's going to be a logic error. At least one. But the implementation's coming along. The translation, conversion. Ugh. I hope I can get it as crazy optimized as the push solve, where like fluff just sort of went away from the algorithm, and instead of like having a fallible function signature, it was able to like lock in and have a guaranteed output. That's what I want for this as well, is either the algorithm itself is wrong, or you get a guaranteed result. Working towards that. Okay. Yes. Okay. Goodbye. I will stream again tomorrow.